Let us look at the pancake problem again. Assuming the pancake is a cylinder, the formula to calculate the volume of a cylinder is V equal to pi r square h. Suppose we keep the height constant, so we will have V equal to pi h r square. The above volume would be a function in terms of radius. In other words, knowing the radius of the cylinder would allow us to calculate the volume of cylinder. If we want to calculate the gradient at point A, we could calculate the gradient of the red triangle as an approximate value of the gradient at A. Given that the change in volume is delta V and the change in the radius is delta R, the gradient of the point at A could be approximated as delta V over delta R. Although this value is not an exact value of the gradient at point A, we can see that if we limit the change delta R over a smaller value, although this value is not an exact value of the gradient at point A, the gradient obtained would be a relatively more accurate reflection of the actual gradient at A. So we have this relationship delta V over delta R is approximately equal to the gradient at point A, and that's provided the change in R is small. In other words, the change in volume could be approximately found by multiplying the gradient function by the change in R at point A. So, to conclude, for a small change in radius, we can obtain the approximate volume change by taking the product of the gradient function and the change in radius.